A team of scientists from the New Hope Fertility Center in New York, under the leadership of Dr. John Zhang, made medical history last year. They did what nobody had ever done before. They created a human being unlike any other on the planet, a baby with 3 biological parents. The parents requested that the baby's face be blurred. Apart from the mother's and father's genes, this baby also carries genes from a third person. The parents are Jordanian and asked Dr. Zhang to do this because the mother is a carrier of a severe genetic disorder. Healthy genes from a third person would ensure that the baby would be born free of a terrible disease, Lee syndrome.
The person suffer from this problem usually cannot walk, cannot eat, because their cell cannot produce enough energy to do the job to contract the muscles.
Professor Michael Pepper of the University of Pretoria explains that Lee syndrome is a severe neurological disorder.
So Lee syndrome is a defect in the DNA of the mitochondria. It leads to a disease, a neurological disease, which involves both mental and motor function. It is lethal in the sense that children will die within the first 2 years, usually from respiratory failure.
Every cell in the human body, including eggs produced by females, contain mitochondria. A cell consists, among other things, of an outer membrane, mitochondria, and a nucleus. Dr. Zhang has a favorite analogy through which he explains the function of the nucleus and the mitochondria. He uses the analogy of a chicken egg.
So we know chicken eggs has egg yolk and egg white, 2 parts. Egg yolk carry all the DNA genetic material to determine who you are. Egg white, it only provides energy. It only provides the cell machinery to let this egg yolk to function the way they're supposed to be, to determine who you are. So yes, you get the egg white from third party, but egg white does not contribute into the genetic makeup to determine who you are and your behavior and what you're doing.
So, in Dr. Zhang's analogy, the egg white represents the mitochondria of a cell that provides the egg yolk, which represents the nucleus, with the energy to develop fully. Both the nucleus of a cell and the mitochondria contain DNA. But sometimes the mitochondria malfunction because DNA in the mitochondria is faulty.
The vast majority of genes which compose this DNA are to be found in the nucleus and not in the mitochondrion. But those in the mitochondrion are essential for life. So if they are disrupted in any way and their products are not synthesized, this then has serious consequences for the affected individual.
These disruptions can lead to Lee syndrome. The couple with whom John worked had already lost 4 babies to this disease. Lee syndrome occurs when faulty mitochondrial DNA cannot provide the nucleus with enough energy for normal growth, like batteries not supplying enough power to the nucleus. This results in a fatally diseased baby. However, there is a procedure that can address this problem, and it is fairly simple. It is called a nuclear transfer, and it can solve the problem of faulty mitochondria. The technology required to carry out the procedure has been available for some time, but has never been approved for use on humans. In an extremely bold and progressive move, the British Parliament approved the technique last year.
The eyes to the right, 382. The nose to the left, 128.
It is so far the only country in the world that has approved the procedure for humans. However, Dr. Zhang and his team performed the procedure in Mexico because that country has no regulations preventing its use. During the nuclear transfer, 2 eggs are used, one from the mother who has a mitochondrial defect and one with healthy mitochondria from a donor. The nuclei from both eggs are removed. Then the nucleus from the mother's egg is inserted into the egg with the healthy mitochondria. This creates an egg with a nucleus from the mother and uncompromised mitochondria from a donor.
One then takes that reconstituted egg and fertilizes that egg with the father's sperm. So in other words, what you end up with is nuclear DNA from the father, nuclear DNA from the mother, and mitochondrial DNA from the donor mother. And this is why people speak of 3-parent babies.
When the fertilized cell begins to divide to form an embryo, all the resultant cells now have healthy mitochondria to provide cellular energy. When the procedure was approved in the UK, regulations stipulated that the third person involved does not have any parental claims. The reason for this is that the DNA of the nucleus contains roughly 25,000 genes. These genes are from the parents and are the building blocks that make up a unique individual. The mitochondrion contains only 37 genes, and that is all that the donor contributes to the genetic makeup of the baby. So the third person only donates a fraction of 1% of the genes of a person born this way. The baby was born 10 months ago, and the procedure was severely criticized, as many new advances are. For example, when the first test tube baby was born in 1978, 80% of the reaction was negative.
When the world's first heart transplantation was done in South Africa, 90% of the comments was negative.
But both procedures are now run-of-the-mill. Advances in genetic research now make it possible to identify literally hundreds of genetic disorders in parents who are carriers of diseases and in affected embryos. But fixing these disorders instead of discarding or destroying the diseased embryos is the next challenge in the field. And what Dr. Zhang and his team have achieved is a first step in that direction. Nuclear transfer can now begin to treat a multitude of diseases that are the result of flawed mitochondrial DNA. However, there are also potential risks associated with the procedure.
As with any form of treatment, you have to weigh up the benefits versus the risks. So what is the benefit here? The benefit is that this couple has now been able to conceive and to have a child that thus far is normal. The risk is that maybe something will happen later on, although there's no evidence at this point that strongly points in the direction of there being any complications.
It is expected that many more babies with 3 parents will be born this year, especially in the UK, where this is now legal. And by tampering with the genes of embryos, the spectre of designer babies is raised. Parents can already choose gender, hair, and eye color of offspring. So will we one day be able to select even more physical features when creating a baby?
Once you know all the gene structure which contribute to different features, then easily you can design.
The work done by Dr. Zhang and his team has been criticized and even been called Frankenstein science by some opponents. However, the first human ever created from the DNA of 3 people seems to be thriving.
Up to today, the bird boy is still perfect, healthy, and so I can't say too much, but baby is very cute. And this is not the end of the story. This is the beginning of the new chapter.